Snow over a control room is not how people imagine secrets being kept. The image online is always darker, alarms flashing, voices hushed, something hidden behind locked doors. A single viral claim spreads fast. NASA knows. NASA has always known. A return cycle is coming, and the truth is being buried. The idea feels powerful because it suggests that somewhere, someone is watching the sky with knowledge we do not have. It feels unsettling because it implies time is running out. The question underneath all of it is simpler and far more serious. If something truly were returning on a predictable cycle, something large enough to affect Earth, would NASA have to know? And, more importantly, could they hide it? To answer that, we have to step away from the drama and look at how knowledge of the sky actually works. NASA did not begin as a secret-keeping organization. It was created in 1958, during the Cold War, when fear of surprise from above was very real. Satellites, missiles, and space were no longer abstract ideas. They were national security concerns. From the beginning, watching the sky was not optional. It was survival. Programs to track objects in orbit, near-Earth asteroids, comets, and distant bodies grew over decades, not in isolation, but in public view. Data was shared with universities, observatories, and later with international partners. Astronomy did not belong to one nation. It never had. The idea of a return cycle suggests repetition. Something came before, and it is coming again. That idea is emotionally powerful, but emotionally powerful ideas are not the same as measurable ones. In astronomy, cycles leave marks. They leave changes in motion, shifts in gravity, disturbances in orbits. Planets do not pass quietly. Large bodies do not drift unnoticed through the inner solar system. Long before they arrive, they announce themselves through math, through telescopes, through effects that can be checked by anyone with access to the data. The modern internet collapses distance between rumor and authority. A post made in one country can feel as convincing as a press release from a space agency. When fear mixes with uncertainty, people look for a single watcher, a single keeper of truth. NASA becomes that symbol, not because it is all-powerful, but because it is visible. The control room becomes a stand-in for the unknown. Snow over the console, lights dimmed, knowledge locked away. But the reality of watching the sky is far less dramatic and far more crowded. Thousands of professionals and amateurs scan the heavens every night. Automated surveys map the sky again and again. Data is copied, mirrored, checked, and debated. If something were returning on a fixed cycle, it would not belong to one agency. It would belong to the sky itself. This chapter begins with a claim, but it does not end with belief or disbelief. It begins with a question that must be answered carefully. Not do you feel like NASA knows, but how would anyone know at all? That is where the investigation truly starts. People hear the word Anunnaki and imagine something watching the Earth from the sky. That image did not exist in the ancient world. The Anunnaki were a group of gods in Mesopotamian belief, appearing in Sumerian and later Akkadian texts that are more than 4,000 years old. These texts were written on clay tablets in cities like Ur, Nippur, and Babylon. They describe a universe ordered by divine authority, not by visitors from space. The Anunnaki were part of a religious system meant to explain why kings ruled, why laws mattered, and why nature followed patterns that humans could not control. In the earliest Sumerian language sources, the word Anunnaki roughly refers to the offspring of the sky god An and the earth goddess Ki. They were not a single race or council with a fixed number. Different texts, name different members depending on the story and purpose. Sometimes they appear as judges of the underworld. Other times, they are simply powerful gods who decide fate. The important point is that they are symbolic figures within mythology. They are not described as physical beings traveling between planets or arriving in machines. Ancient Mesopotamian religion was deeply connected to daily life. Floods, droughts, war, and disease were constant threats. Gods provided meaning in a dangerous world. The Anunnaki helped explain why suffering existed and why order sometimes failed. When cities fell or kings died, priests did not look to the sky for returning visitors. They looked to rituals, offerings, and signs within their religious tradition. The texts speak in poetic and symbolic language, not technical description. Much of the confusion comes from reading ancient writing through a modern lens. Words like heaven, sky, and descent appear often, but they reflect how ancient people understood the world. The sky was the realm of the gods because it was unreachable and powerful. Saying a god descended did not mean a spacecraft landed. It meant divine influence entered human affairs. These metaphors were common and understood by their audience. Modern translations of Sumerian and Akkadian texts began in the 19th century, as archaeology uncovered libraries buried for thousands of years. Scholars spent decades learning the languages, comparing fragments, and rebuilding meaning line by line. None of this academic work described the Anunnaki as aliens. That idea appears much later, shaped by modern science fiction, space exploration, and distrust of authority. When people today say Anunnaki, they are often referring to a modern reinterpretation, not the ancient belief itself. The original texts describe gods tied to land, temples, and kingship. They do not describe a return cycle, hidden technology, or secret knowledge of space. Understanding this difference matters. Without it, myth becomes mistaken for history, and symbols become taken as literal facts. To understand any claim about the Anunnaki, we must first understand who they actually were in the world that named them. This clarity sets the foundation for examining later claims without fear, confusion, or unnecessary mystery about the sky and modern institutions. Myth is not a diary of events. In the ancient world, it was a tool for explaining power, order, and meaning. The texts that mention the Anunnaki were written by temple scribes, serving kings and cities, not historians recording eyewitness accounts. These writings include hymns, prayers, royal inscriptions, and ritual instructions. Their purpose was to connect human authority to divine approval. When a king claimed descent from gods, it was not a genetic statement, it was a political one. Divine lineage meant legitimacy, stability, and right to rule in a dangerous world. Sumerian and Akkadian literature used repetition, exaggeration, and symbolism by design. Gods were described as larger than life because they represented forces beyond human control. When a text says a god shaped humanity or decided fate, it is expressing a worldview, not a laboratory experiment. Ancient readers understood this. They did not expect literal measurements or technical detail. The language was sacred, not scientific. Temple archives show that many stories existed in multiple versions. Names changed, roles shifted, gods merged or separated over time. This fluidity tells us these texts were not fixed records. They were living traditions adapted to local needs. A hymn in one city might emphasize one god. Another city might elevate a different one. The Anunnaki appeared differently depending on the setting, which would not make sense if they were physical beings with a single objective history. Modern confusion often begins when myth is read as memoir. Phrases like descended from the heavens or came down to earth sound physical to modern ears trained by space travel and science fiction. In the ancient context, heaven meant authority and mystery. Earth meant human life and struggle. Movement between them described influence, not transportation. No tablets describe machinery, propulsion, or materials. What they describe are rituals, offerings, and moral duties. Kings used these stories carefully. By placing themselves within divine order, they strengthened loyalty and obedience. Laws were said to come from the gods. Victories were credited to divine favor. Defeats were blamed on divine anger. This system worked because people shared the same symbolic language. It was never meant to be questioned as a literal timeline of events. Archaeologists and linguists studying these texts rely on context. They compare grammar, metaphor, and usage across thousands of tablets. This method shows consistency in symbolic meaning, not hidden technical messages. When later readers ignore that context, they create meanings the original authors never intended. Understanding myth as myth does not weaken ancient cultures. It respects them. It recognizes that they explained their world with the tools they had. Treating these texts as coded space records strips them of their real historical value. To understand claims about ancient beings returning, we must first accept that the source material was never written as a record of visitors. It was written to explain why human society existed as it did, and why order mattered in a fragile world. This perspective grounds interpretation and prevents confusion across time and belief systems. The word Nibiru did not begin as a warning or a threat. In ancient Mesopotamian texts, it appears as a term connected to movement and crossing. In some contexts, it refers to a celestial marker, often linked to the path of a planet or a point in the sky associated with the god Marduk in Babylonian tradition. It was not a hidden planet waiting to return. It was a flexible word used differently across texts, sometimes meaning crossing place, sometimes a reference point, sometimes a title connected to authority in the heavens. Ancient scribes did not agree on a single definition, and they did not treat Nibiru as a physical world on a long, destructive orbit. Modern confusion began when this ancient term was pulled out of its context and placed into a modern fear narrative. In the late 20th century, as space exploration became part of daily news, ideas about unknown planets captured public imagination. Astronomers had once used the phrase Planet X as a temporary label for an unseen object that might explain small irregularities in planetary motion. This was a scientific placeholder, not a prophecy. Over time, that cautious idea merged online with Nibiru, despite the lack of connection between the two. The Doomsday version of Nibiru describes a massive planet on an extreme orbit, returning every few thousand years to pass near Earth. This version did not come from ancient tablets. It came from modern speculation, selective translation, and repetition across books, websites, and videos. Dates were attached, often precise, then quietly abandoned when nothing happened. Each failure led to a new explanation rather than a correction. The story survived by changing details while keeping the fear intact. In actual ancient astronomy, Mesopotamian scholars were careful observers. They tracked planets, eclipses, and cycles with impressive accuracy for their time. Their records were meant to predict seasons and ritual timing, not disasters from space. If Nibiru had been understood as a dangerous returning planet, it would appear consistently and clearly in their astronomical tablets. It does not. The evidence instead shows symbolic and religious usage, not orbital mechanics. The modern Planet X narrative also ignores how astronomy works today. A large object moving through the inner solar system would affect the motion of known planets. Those effects would be visible in data long before a close approach. Ancient Nibiru texts do not describe such behavior, and modern observations do not support it. The word carries baggage now because it has been reshaped into a symbol of hidden danger. Separating the ancient term from the modern storyline is essential. One belongs to myth and religious language. The other belongs to internet culture and fear-driven speculation. Confusing the two creates the illusion of an ancient warning that never existed. Understanding this difference allows discussion to move forward based on evidence rather than inherited anxiety. This clarity helps audiences evaluate claims calmly and encourages critical thinking when extraordinary statements appear without sources or measurable proof in public online spaces. Modern prophecies are not born in ancient stone. They are built step by step in the present. The Nibiru doomsday narrative began taking its modern shape in the late 20th century, at a moment when space became both familiar and frightening. Humans had walked on the moon. Probes were leaving the solar system. At the same time, the Cold War trained people to expect sudden disaster from above. This mix created fertile ground for ideas that blended astronomy, fear, and hidden knowledge. In the 1970s and 1980s, books and lectures began claiming that ancient cultures knew more than modern science admitted. These works often presented themselves as revelations rather than arguments. They borrowed ancient names like Nibiru, removed them from scholarly context, and inserted them into a new framework. In this framework, modern institutions were not explorers of space, but gatekeepers of forbidden truth. Evidence was promised, but rarely shown in full. A key feature of modern prophecy is the use of dates. Dates create urgency. They turn vague concern into countdown. Over the years, Nibiru was said to arrive in the late 1990s, then the early 2000s, then around the year 2012, tied loosely to the Mayan calendar. Each date passed without event. Instead of ending the claim, the story adjusted. The orbit changed. The calendar was misunderstood. The information was suppressed. The prophecy survived by moving forward. Fear plays an equally important role. The narrative frames ordinary uncertainty as danger. Scientific language is used selectively to sound credible, while complex details are avoided. Terms like gravitational shift or pole reversal appear without explanation. This vagueness allows listeners to fill gaps with imagination. The less specific the claim, the harder it is to disprove emotionally, even when it fails physically. The internet accelerated this process. In the early 21st century, online forums, video platforms, and social media allowed these ideas to spread without review. A dramatic video could reach millions faster than a scientific paper could reach hundreds. Algorithms favored emotion over accuracy. Fear kept attention. Attention brought influence. Influence created communities that reinforced belief and dismissed contradiction as part of the cover-up. What makes these modern prophecies resilient is not evidence, but structure. They offer secret knowledge. They divide the world into those who know and those who sleep. They explain uncertainty with intention. Nothing happens by accident. Every denial becomes proof of conspiracy. This structure mirrors earlier doomsday movements throughout history, from failed religious end-time predictions to more recent technological panics. Understanding how this prophecy is made does not require mocking belief. It requires recognizing patterns. When claims rely on moving dates, unclear mechanisms, and accusations of hidden truth, they are insulated from testing. The Nibiru narrative did not grow because new data supported it. It grew because fear, repetition, and vagueness made it adaptable. Recognizing this process is essential before asking whether any institution knows a secret. First, we must understand how the story itself was built and why it continues to survive without confirmation. In 1976, a single book changed the direction of the Anunnaki conversation. Zecharia Sitchin published The 12th Planet, presenting it not as fiction, but as a correction to history. His central claim was simple and dramatic. Ancient Sumerian texts, he argued, described not gods, but extraterrestrial beings from a distant planet called Nibiru. According to Sitchin, this planet followed a long elliptical orbit and returned to the inner solar system on a regular cycle. The Anunnaki, in this view, were not symbolic deities. They were physical visitors who shaped human civilization. This idea became the bridge between ancient mythology and modern alien belief. Sitchin was not an archaeologist or a trained Assyriologist. His background was in economics and journalism. He taught himself to read some ancient symbols, but his translations were not accepted by academic experts in Sumerian or Akkadian languages. Scholars who had spent decades studying these texts pointed out that his readings ignored grammar, context, and established meanings. Words he interpreted as rockets, astronauts, or planets were known terms for gods, stars, or ritual ideas. The criticism was consistent and public. Despite this, the book found a wide audience. It arrived at a moment when trust in institutions was low and curiosity about ancient mysteries was high. Space exploration had expanded imagination. Science fiction had blurred into possibility. Sitchin's work offered something powerful. It suggested that history was wrong and that readers were being invited into hidden truth. The appeal was emotional, not academic. The pivot mattered because it reframed everything that came before. Ancient gods became engineers. Myths became technical reports. Symbolic language was treated as literal description. From that point forward, later writers and creators did not need to prove the idea, they only needed to repeat it. The Anunnaki became aliens by default in popular culture, even though the original texts never made that claim. Sitchin's timeline also introduced the idea of a return. If Nibiru had an orbit, it must come back. This fit perfectly with modern fears and ancient language about cycles. Yet no ancient tablet gives orbital measurements, dates, or physical descriptions that match a real planet. These details were supplied by interpretation, not evidence. Academic response did not slow the spread. Critical papers and linguistic breakdowns existed, but they did not travel as far as sensational claims. Once the idea entered popular culture, it became self-sustaining. Later, Nibiru prophecies, internet theories, and videos often reference Sitchin directly or indirectly, even when they move beyond his original arguments. Understanding the Sitchin pivot is essential because it explains how a religious concept became a cosmic threat. The shift did not come from new archaeological discoveries. It came from reinterpretation presented as revelation. This does not require assuming bad intent. It requires recognizing the difference between scholarly consensus and personal theory. From this point forward, discussions about Anunnaki and return cycles are no longer rooted in ancient belief systems. They are rooted in a modern framework shaped in the late 20th century. Once that pivot occurred, the question changed. It was no longer, what did ancient people believe, but who knows the truth now? That question sets the stage for examining modern institutions, especially NASA, and whether secrecy is even possible in a sky watched by many. Translation is never just about swapping one word for another. It is about choosing meaning. Ancient languages like Sumerian and Akkadian are complex, layered, and deeply tied to culture. A single symbol can carry multiple meanings depending on context. Professional translators do not pick the most exciting option. They pick the one that fits grammar, usage, and the surrounding text. When that process is ignored, mythological language can be reshaped into something it was never meant to be. Many of the claims about hidden history begin with a small shift. A word that means sky becomes space. A word that means God becomes being. A word that means shine becomes craft. Each choice seems minor, but together they transform poetry into technology. Ancient scribes wrote for audiences who understood metaphor instinctively. They did not need footnotes to explain symbolism. Modern readers often do not share that instinct, and that gap invites reinterpretation. For example, ancient texts frequently describe gods as radiant or shining. In religious language, light represents power and presence. Modern readers raised on images of spacecraft and engines may see something else. Without context, the symbol becomes literal. The same happens with words translated as descended or ascended. In ancient usage, these words describe changes in influence or status. They do not describe physical travel in a mechanical sense. Academic translation works slowly. It relies on comparing thousands of tablets, tracking how words are used across centuries. When a term appears in legal texts, hymns, and letters with similar meaning, scholars gain confidence in its definition. This process removes mystery, which makes it less attractive to sensational retelling. But it is how history is responsibly reconstructed. Interpretive leaps often ignore this method. They isolate a single line, remove it from its setting, and build a theory around it. When challenged, the response is often that scholars are hiding the truth or are unwilling to see what is obvious. This reverses the burden of proof. Instead of evidence supporting the claim, doubt is cast on the entire field. The difference between translation and interpretation matters because it defines credibility. Translation asks what the text most likely meant to its original audience. Interpretation asks what it could mean to us now. Both have value, but they are not the same. Problems arise when interpretation is presented as translation. At that point, opinion is dressed as fact. In the case of the Anunnaki, this distinction explains how ancient gods became modern visitors. No new tablets were found saying this. No new linguistic discoveries forced a rewrite. The change came from interpretive preference. Certain meanings were chosen because they aligned with modern expectations about space and technology. This process is not unique to this topic. It appears in many claims about ancient knowledge, lost civilizations, and secret histories. The pattern is consistent. Take symbolic language, apply modern imagery, and present the result as suppressed truth. It feels convincing because it connects past and present in a dramatic way. Understanding translation discipline does not require expertise in ancient languages. It requires respect for context and caution with certainty. When a claim depends on a single translated word carrying an extraordinary meaning, that claim deserves scrutiny. History becomes distorted not by large lies, but by small, unchecked choices. Recognizing this helps separate what ancient texts actually say from what we want them to say today. A return cycle sounds simple until it is translated into physics. In astronomy, a cycle means an orbit that can be measured, predicted, and tested. For an object to return to the inner solar system on a regular schedule, it must follow a stable path shaped by gravity. That path would have a defined period, distance, tilt, and interaction with other planets. These are not abstract ideas. They are numbers that leave evidence behind. A large object moving on a long orbit would spend most of its time far from the sun, but not invisible. Gravity does not turn off at distance. As such an object moves, it would subtly affect the orbits of known planets, especially the outer ones. Astronomers track these motions with extreme precision. Even small irregularities are noticed and studied. A returning body massive enough to threaten Earth would produce disturbances long before it arrived. Detectability is not optional in orbital mechanics. An object does not need to be close to be known. Its mass and motion reveal it. Comets with long periods are discovered decades before they approach. Distant objects beyond Neptune are tracked through repeated surveys. Modern telescopes scan the sky methodically, mapping positions night after night. A predictable return cycle would stand out in this data. The idea of an extreme elliptical orbit often appears in return cycle claims. Such orbits are unstable over long times. Gravitational pulls from Jupiter and Saturn would alter the path with each pass. Over thousands of years, the cycle would change or break entirely. This is why long-term stable orbits are limited and well studied. Nature favors balance, not dramatic repetition. Another requirement is visibility. A large planet-sized object reflecting sunlight or emitting heat would be detectable by optical and infrared surveys. It could not hide behind the sun indefinitely. It would cross regions of the sky watched by many instruments. Even amateur astronomers regularly discover new comets and asteroids using small equipment. The sky is not monitored by one group. It is monitored by thousands. Claims that an object appears suddenly ignore this process. Sudden arrival contradicts how motion works. Objects move continuously. Their paths are traced backward and forward through time. When astronomers discover something new, they calculate where it came from and where it is going. A return cycle would already be written into those calculations. Historical records support this understanding. Since the early 19th century, astronomers have predicted planets before seeing them based on gravitational effects. Neptune was found this way. That success reinforced confidence in orbital mechanics. It showed that massive objects cannot remain hidden if they interact with known bodies. When the idea of a return cycle is examined physically, it becomes a testable claim. What is the mass? What is the orbit? What effects does it cause? Without answers, the claim remains a feeling, not a mechanism. Physics does not care about belief. It responds to measurement. This matters because it shifts the discussion from fear to evidence. A true return cycle would not be secret knowledge. It would be a shared discovery, unfolding gradually through data. Understanding these requirements prepares us to evaluate claims realistically. It reminds us that the universe follows rules that can be checked, not narratives that rely on surprise. The sky does not hide large objects quietly. Gravity is not subtle when mass is involved. A massive body entering the inner solar system would announce itself long before it became visible to the eye. Every planet moves in a predictable path shaped by gravitational balance. When that balance is disturbed, the motion changes. Astronomers watch for these changes constantly because they reveal what cannot yet be seen. This method is not new. In the early 19th century, irregularities in the orbit of Uranus led astronomers to predict the existence of another planet. That prediction was based entirely on gravity. Neptune was discovered in 1846, almost exactly where calculations said it should be. No telescope stumbled upon it by accident. The sky gave away its secret through motion. That same principle applies today with far greater precision. A massive intruder would pull on Jupiter, Saturn, and the outer planets first. Those planets act like sensors because of their size. Their paths are measured with incredible accuracy using radar, spacecraft tracking, and long-term observation. Deviations are logged, analyzed, and debated. A returning planet large enough to threaten Earth would produce effects too large to ignore. Even smaller objects leave traces. Comets from the distant Oort cloud are tracked as they fall inward. Their trajectories are mapped years in advance. Astronomers can tell whether a comet is making its first visit or returning on a known path. This is possible because gravity leaves a record. Motion remembers where it has been. Modern surveys multiply this effect. Ground-based telescopes scan the sky repeatedly, building catalogues that compare positions over time. Space-based observatories extend this reach into infrared, where heat reveals objects that reflect little light. These systems are designed specifically to find what is hidden. They do not wait for announcements. They look continuously. Claims of a massive object appearing suddenly rely on a misunderstanding of scale. Sudden to a human calendar is not sudden to physics. An object moving through the solar system takes years to cross meaningful distances. During that time, it affects everything around it. Its influence spreads faster than its visibility. Gravitational evidence cannot be locked in a vault. Data comes from many countries, universities, and independent observers. Calculations are repeated by different teams using different methods. If something were pulling on the solar system, disagreement would appear in published results. That disagreement would spark investigation, not silence. This is why secrecy claims struggle under scrutiny. To hide a massive intruder, one would have to alter or suppress vast amounts of data across unrelated institutions worldwide. That would require coordination beyond realistic human capacity. Astronomy is competitive, not centralized. Discovery brings recognition. No incentive exists to hide a real object. Historical patterns support this view. Every major solar system discovery has followed the same path. An anomaly is noticed. Hypotheses are proposed. Observations confirm or reject them. Debate happens in public. That process has not changed. The sky does not whisper secrets to one listener. It speaks through motion that anyone trained to listen can hear. If a massive intruder were approaching, its gravity would already be telling the story. The silence of that evidence matters more than any claim made without it. NASA is asked about Planet X and Nibiru again and again because it sits at the intersection of fear, authority, and space. When people believe something is being hidden, they look toward the most visible institution watching the sky. NASA becomes the symbol of knowledge even when it is not the sole holder of data. The phrase Planet X has a real scientific history that is often misunderstood. In the early 20th century, astronomers used it as a temporary label for an unseen cause of orbital irregularities. It was never a name for a confirmed planet or a prediction of disaster. As measurements improved, many irregularities disappeared and the label fell out of use. Despite this scientific background, the term was adopted by online communities searching for meaning in uncertainty. Nibiru was merged with Planet X and transformed into a single hidden object with intent. Questions and emails began reaching NASA in large numbers, especially after failed prediction dates. NASA responded publicly through articles, interviews, and frequently asked question pages. The responses were direct, stating that no such planet exists and no evidence supports the claims. To believers, these denials often strengthened suspicion rather than resolved it. This reaction follows a known pattern where authority statements are reinterpreted as proof of concealment. NASA does not control astronomy, nor does it operate in isolation. Its data is shared with universities, international observatories, and independent researchers worldwide. Many discoveries that challenge existing models come from outside NASA entirely. When NASA says there is no evidence, it reflects the absence of measurable effects, not a refusal to look. Planetary science advances by publishing uncertainty, not by hiding it. The repeated questions reveal more about public anxiety than about secret knowledge. Space feels vast and threatening, and people seek reassurance that someone is paying attention. NASA becomes the listener for those fears. Understanding NASA responses means understanding their limits. They do not promise absolute certainty, but they do promise transparency within evidence. When evidence changes, statements change, and history shows that clearly. The Planet X problem is not that NASA knows something hidden, but that fear asks the wrong question. The right question is how knowledge is built, shared, and corrected over time. That process is slow, public, and deeply resistant to secrecy. Looking at NASA through this lens removes mystery and replaces it with method. Methods can be questioned, tested, and improved. Secrets cannot survive that environment for long. This is why repeated denials remain consistent across decades. There is nothing new to hide because there is nothing there to measure. Understanding this helps move the conversation forward. It shifts focus away from suspicion and toward how science actually works. That shift matters when evaluating any extraordinary claim about the sky. Extraordinary claims require evidence that can stand in public light. So far, the Planet X narrative has not met that standard. NASA answers reflect that absence, not a secret countdown hidden in the dark of space programs worldwide today and beyond now. The search for a hidden giant did not rely on guesswork. It relied on infrared light. In 2009, NASA launched the Wide Field Infrared Survey Explorer, known as WISE, with a clear mission: map the entire sky in infrared and detect objects that ordinary telescopes might miss. Infrared matters because large cold objects emit heat even when they reflect little sunlight. A planet-sized body lurking nearby would glow in this range. It could not hide by being dark. WISE scanned the sky multiple times over its primary mission and later extended missions. It detected hundreds of millions of objects, including asteroids, brown dwarfs, distant galaxies, and faint stars. Many of these objects were unknown before the survey. This alone matters. If something large and close were there, WISE would not skip it. Its sensitivity was designed to find precisely the kind of object described in Nibiru claims. After the data was analyzed, scientists published clear results. No Jupiter-sized or Saturn-sized object exists within a vast region beyond Pluto. No massive planet is moving toward the inner solar system. These conclusions were not opinions. They were limits defined by observation. For example, a Jupiter mass object would have been detected out to distances far beyond the edge of the Kuiper belt. The absence of detection means absence of object within those ranges. This did not end the narrative. Instead, the story shifted. Claims appeared saying the object was smaller, colder, hidden behind the sun, or invisible by unknown means. Each adjustment reduced the threat while preserving belief. But physics does not adjust to narrative. Infrared detection is not fooled by location or shadow. The sun does not block the sky permanently. Orbits move. Surveys repeat. WISE data was not kept secret. It was released publicly. Independent researchers used it to discover nearby stars and map the solar neighborhood. Amateur astronomers accessed the same catalogues. If a giant object were present, it would not require permission to be seen. It would already be in the data. The importance of WISE lies in what it ruled out. It did not claim to know everything. It set boundaries. Within those boundaries, the popular versions of Nibiru cannot exist. A massive nearby planet with a return cycle would fall well within detection limits. It does not. Infrared surveys changed astronomy by revealing the unseen. They expanded knowledge rather than closed it. That expansion makes secrecy harder, not easier. The missing giant is missing because it is not there, not because it was overlooked. Understanding this helps ground the discussion. When people ask whether NASA knows about a hidden planet, the better question is what the data shows. In this case, the data speaks clearly. The sky was scanned. The heat was measured. The giant did not appear. This does not remove wonder from the universe. It refines it. Real mysteries remain, but they are framed by evidence. Wise closed one door by opening many others. The absence of a Nibiru-sized object near Earth is not a cover-up. It is a result, tested and shared, waiting in the open for anyone willing to look. Science is careful about what it claims to know. NASA cannot prove a negative in the absolute sense, and it does not pretend to. It cannot say that nothing exists anywhere forever. What it can do is define limits based on observation. Those limits matter because they tell us what is possible and what is not within the space we can measure. This distinction is often misunderstood and exploited by conspiracy narratives. Astronomical surveys work by scanning defined regions of the sky with known sensitivity. They can say with confidence that objects above a certain size and brightness do not exist within a certain distance. When NASA says there is no evidence for Nibiru or a planet X near Earth, it means no object matching the claimed properties appears in the data collected so far. That is not a philosophical statement. It is a technical one. What remains theoretically possible is narrow and specific. Small objects, far beyond the reach of current instruments, could exist. Cold bodies with low mass in distant regions, like the outer Oort cloud, might remain undetected. These objects would not affect Earth. They would not have dramatic return cycles. They would not interact strongly with the planets. Possibility does not equal relevance. The problem arises when this careful language is misused. Some claim that because NASA cannot rule out every imaginable object, any story is valid. This is a misunderstanding of how evidence works. Science advances by narrowing uncertainty, not by allowing all ideas equal weight. If a claim requires properties that fall within ruled-out limits, that claim fails, regardless of remaining unknowns. For example, a massive planet returning to the inner solar system would need to be large enough to matter. That size places it within detection limits already surveyed. Saying it could still exist because absolute proof is impossible ignores the scale involved. A grain of sand and a mountain are not treated the same way. NASA's caution is a strength, not a weakness. It avoids overstating conclusions and invites further testing. When new instruments come online, limits are updated. This has happened many times in history. Pluto was discovered, reclassified, and placed in context as knowledge improved. Each change was public and debated. Understanding limits also explains why science does not chase every rumor. Resources are finite. Observations are prioritized based on evidence, not fear. Claims without testable predictions do not guide telescopes. If someone cannot specify where to look, when to look, and what effect to expect, there is nothing to measure. The phrase "cannot prove a negative" becomes powerful when separated from context. It suggests doubt where there is none. In reality, it describes humility. It acknowledges that knowledge is incomplete while still acting on what is known. That balance keeps science honest. In the case of return cycle claims, what remains possible does not support the narrative. The remaining unknowns are too small, too distant, and too weak to fit the story. They are interesting scientifically, but irrelevant to fear-based predictions. Clarifying this helps move the conversation forward. It replaces absolute thinking with measured understanding. NASA does not claim omniscience. It claims responsibility to evidence. Within that framework, extraordinary claims must meet extraordinary standards. So far, the idea of a dangerous returning object has not met them, and the limits placed by observation explain why. There is a real mystery at the edge of the solar system, and it is often confused with myth. Planet 9 is not Nibiru by another name. It is a scientific hypothesis proposed in the mid-2010s to explain unusual patterns in the orbits of distant icy objects beyond Neptune. Astronomers noticed that several of these objects shared similar orbital alignments. By chance alone, this clustering was unlikely. The question became, what could cause it? Researchers suggested that a previously undiscovered planet, several times the mass of Earth and orbiting very far from the Sun, might explain the pattern. This idea was based on math, not ancient texts. It did not predict disaster. It did not predict a return to the inner solar system. It proposed a distant, slow-moving body whose gravity gently shaped the outer region over millions of years. The difference between this hypothesis and internet mythology is method. Planet 9 research began with observation, followed by calculation, followed by testable predictions. Scientists published their work openly, invited criticism, and adjusted models as new data appeared. Some astronomers agree the evidence is compelling. Others argue alternative explanations exist, such as collective effects from many smaller objects. This debate is public and ongoing. Importantly, Planet 9 is expected to be extremely distant. Its orbit, if it exists, would take thousands of years to complete one revolution. It would never approach Earth. It would not suddenly appear in the sky. It would not cause earthquakes or floods. It is interesting because it helps explain structure, not because it threatens life. Internet mythology often borrows the name Planet 9 to give older fears a new coat. The logic goes that if scientists admit a planet might exist, then anything is possible. This is a leap. Science allows possibility within constraints. The proposed planet has defined limits on mass, distance, and behavior. Those limits do not overlap with doomsday narratives. Another key difference is transparency. Planet 9 research relies on data from many telescopes worldwide. No single agency controls it. When new surveys fail to find the planet, that information is shared too. The hypothesis weakens or strengthens based on results. That is how real uncertainty is handled. This process contrasts sharply with mythology. Mythology does not update based on failure. It adapts stories to preserve belief. Science does the opposite. It discards ideas that no longer fit evidence. If Planet 9 is not found, the hypothesis will fade. If it is found, its properties will be measured and published. Understanding this distinction matters because it shows how mystery and fear diverge. Mystery invites investigation. Fear demands certainty without proof. Planet 9 represents curiosity at the edge of knowledge, not secret knowledge withheld. When people ask whether NASA knows something hidden, Planet 9 offers a useful comparison. Here is a case where something might exist and no one is pretending certainty. No countdowns are issued. No ancient warnings are invoked. The sky is watched patiently. This chapter matters because it shows that real unknowns exist without conspiracy. The universe is not fully mapped, and that is honest. But honest mystery looks nothing like internet mythology. It moves slowly, publicly, and without drama. That difference helps separate what science is actually searching for from what stories want us to fear. Astronomers do not search the sky by waiting for something to appear. They search by building maps and then watching those maps change. Modern sky surveys divide the heavens into sections and scan them repeatedly over time. Each scan records the position and brightness of millions of points. When those points shift, fade, brighten, or move, software flags them for study. This process is slow, methodical, and designed to catch what the human eye would miss. The history of this approach goes back more than a century. In the late 19th and early 20th centuries, astronomers used photographic plates to compare the sky across months and years. Objects that moved relative to background stars stood out. This is how Pluto was discovered in 1930. The method has evolved, but the principle remains the same. Change reveals motion, and motion reveals objects. Today, the scale is far larger. Automated surveys run every clear night. Telescopes in different countries cover different parts of the sky. Some focus on visible light, others focus on infrared. Some watch the same strip repeatedly. Others tile the whole sky over time. Data flows into shared catalogues used by researchers around the world. No single organization controls all of it. This distributed system makes secrecy claims fragile. To hide a real object, every survey would need to miss it or suppress it. That includes university projects, private observatories, and amateur networks. Astronomers compete for discoveries. Finding something new brings recognition, funding, and career advancement. There is no incentive to stay silent about a genuine detection. Sky surveys also produce public alerts. When a new asteroid or comet is found, its orbit is calculated and shared. Independent groups verify the result. Predictions are updated as new observations come in. This transparency is necessary because tracking potential hazards requires cooperation. A hidden object would undermine that system and be noticed through inconsistencies. Claims of secrecy often assume that astronomy works like intelligence gathering. It does not. There is no central command deciding what can be known. Data is messy, shared, and argued over. Mistakes are corrected in public. Papers are challenged. Models are revised. This openness is a feature, not a flaw. Another reason secrecy fails is redundancy. The same region of sky is often observed by multiple instruments for different purposes. A survey looking for asteroids might overlap with one mapping galaxies. A space telescope might revisit areas already scanned from the ground. If an object were present, it would appear in more than one dataset. Cross-checks are routine. Time also works against secrecy. Orbits change predictably. An object cannot hide by staying still. It moves against the background stars. Over months and years, that motion becomes obvious. Even slow-moving distant bodies are revealed by patient observation. Astronomy rewards patience more than surprise. Understanding how astronomers search helps explain why extraordinary claims struggle. A claim that cannot specify where and how an object would be detected cannot guide a search. Without predictions, there is nothing to test. Science requires more than assertion. This process does not eliminate mystery, it frames it. Unknowns exist at the edges of detection, but they are constrained by method and evidence. When people claim that something massive is being hidden, they underestimate how many eyes are watching and how independent those watchers are. The sky is not owned by any agency, it is shared. That shared observation is why secrecy claims fail under scrutiny. Knowledge emerges from comparison, not concealment. Understanding this turns fear into perspective and replaces suspicion with a clearer view of how discovery actually happens. Conspiracies often need a face, and NASA provides one that feels believable. It is large, government-funded, and connected to space, which already feels distant and mysterious. When people imagine hidden knowledge about the sky, they imagine an organization with advanced technology and restricted rooms. NASA fits that image easily, even though the reality is far less dramatic. The agency becomes a symbol rather than a specific actor. Historically, moments of rapid change increase distrust. NASA was created during the Cold War, a period defined by secrecy, military projects, and fear of surprise attack. Space was tied to missiles and surveillance. Even though NASA itself was a civilian agency, its birth in that era shaped public perception. For some, space exploration never fully separated from ideas of classified programs and hidden threats. NASA also communicates carefully. Scientific language is cautious by design. Statements include uncertainty, probabilities, and limits. To someone unfamiliar with how science works, this can sound evasive. When NASA says there is no evidence rather than something does not exist, that precision can be misread as avoidance. Conspiracy thinking thrives in that gap between careful wording and emotional expectation. Another reason conspiracies pick NASA is visibility. NASA has logos, press conferences, and dramatic imagery. Telescopes, rovers, and planets make for powerful visuals. It feels more satisfying to imagine a secret being kept by a famous agency than by a quiet network of universities and amateur astronomers. Simpler stories spread faster. The internet amplifies this effect. Algorithms reward content that provokes emotion. A video claiming NASA is hiding something will travel farther than a paper explaining survey limits. Repetition creates familiarity. Familiarity creates belief. Over time, NASA becomes the default villain in stories that require one. Psychology also plays a role. Conspiracies offer control in uncertain times. Believing that someone knows the truth, even if they are hiding it, can feel safer than accepting randomness. NASA becomes the keeper of order in a chaotic universe. If they know, then events are planned, not accidental. That idea comforts some people, even as it frightens them. It is important to note that NASA is not a single mind. It employs thousands of scientists, engineers, and administrators. Its work is reviewed by external committees and published in journals. Many of its discoveries come from partnerships with other nations. This structure makes long-term secrecy unlikely, but conspiracy narratives flatten complexity. They turn organizations into characters. History shows this pattern repeating. Weather control conspiracies target meteorological agencies. Health conspiracies target public health organizations. Space conspiracies target NASA. The target changes, but the logic remains the same. Central authority becomes suspect by default. Understanding why NASA is chosen does not require assuming bad faith. It requires recognizing how fear, authority, and imagination interact. NASA represents the frontier. Frontiers invite both hope and suspicion. When answers feel incomplete, people fill gaps with intention. Recognizing this dynamic helps separate emotional reaction from evidence. It reminds us that suspicion often says more about human psychology than about institutional behavior. NASA becomes a mirror for anxiety about the unknown. Once that is understood, the question shifts. It is no longer why is NASA hiding something, but why do we need someone to be hiding something at all? This perspective does not demand trust without question. It demands better questions. questions grounded in how knowledge is produced rather than how stories feel. When that shift happens, conspiracies lose their grip, and the sky becomes a place of shared curiosity instead of secret dread. Belief has an economy, even when it claims to reject money. Ideas move through attention, and attention has value. In the modern world, certainty sells better than caution. Fear sells faster than nuance. This is not new, but digital platforms have amplified it. The Nibiru narrative, like many apocalyptic claims before it, did not spread only because people believed it. It spread because belief could be turned into profit. Throughout history, end-of-the-world predictions have often been tied to donations, books, or exclusive access to knowledge. In the 19th and 20th centuries, failed prophecies were followed by new pamphlets, lectures, and movements. Each wave generated income for its leaders. The pattern did not disappear. It adapted. In the late 20th and early 21st centuries, the internet lowered the cost of entry and raised the potential reach. Certainty is key to this economy. Saying something might happen does not hold attention. Saying it will happen does. Dates create urgency. Urgency drives clicks, views, and purchases. A calm explanation that nothing is expected to occur does not compete well against a countdown. Algorithms reward engagement, not accuracy. Content that triggers fear keeps people watching longer. Merchandise often follows belief. Books promise hidden truth. Courses teach survival or awakening. Subscriptions offer updates only insiders receive. Advertising revenue flows to channels that maintain large audiences. None of this requires the claim to be true. It requires the claim to be compelling. The cost of being wrong is low if the date can be moved or the explanation changed. This does not mean everyone involved acts with bad intent. Many genuinely believe what they share, but belief and profit reinforce each other. Once an audience forms, there is pressure to continue. Backing away risks losing followers. Doubt becomes dangerous to the brand. Certainty becomes the product. Fear-based narratives also simplify complexity. Science is slow and uncertain. That does not fit well into short videos or viral posts. Replacing complexity with a single cause and a single villain makes the story easier to sell. NASA becomes the gatekeeper. Nibiru becomes the threat. The world becomes a stage for revelation. The economics of belief also exploit human psychology. Fear narrows attention. It reduces critical thinking. When people feel threatened, they seek guidance. Those offering answers gain authority. That authority can be converted into trust and trust into revenue. The cycle feeds itself. Historical parallels are clear. From religious end-time movements to financial panics, those who claim special foresight often attract followers and resources. When predictions fail, explanations shift. Followers are told the danger was delayed, avoided, or misunderstood. The structure survives even when facts do not. Understanding this economy matters because it explains why certain ideas persist without evidence. They persist because they work as content. They reward confidence, repetition, and emotional charge. They punish correction and humility. This does not mean skepticism should become cynicism. It means claims should be evaluated not only on what they say, but on how they are sustained. Who benefits when fear spreads? Who gains when certainty replaces evidence? These questions do not dismiss belief, they contextualize it. When examining claims about return cycles and hidden knowledge, it is important to follow the incentives. Fear rarely exists alone. It travels with profit. Recognizing that does not answer every question about the universe, but it helps explain why some stories grow louder while quieter truths struggle to be heard. Apocalypse predictions have a long history, and they almost never end when they fail. Instead, they change shape. The pattern is consistent across centuries and cultures. A date is announced. Attention builds. Fear rises. The date passes. Nothing happens. Rather than abandoning the claim, its advocates quietly rewrite the explanation. This is known as moving the goalposts, and it is central to how modern doomsday narratives survive. In the case of Nibiru, specific dates have been named repeatedly. Predictions circulated widely around the late 1990s, then shifted to the early 2000s, then became tightly linked to the year 2012. Each time, the prediction was presented as certain. Each time, it failed. After each failure, explanations appeared. The orbit was misunderstood. The calendar was wrong. The arrival was delayed. The event happened invisibly. The story continued. This behavior is not unique. In the 19th century, religious movements predicted the end of the world on exact days. When nothing happened, leaders reinterpreted the outcome as a spiritual event rather than a physical one. Followers were told their faith had prevented disaster or that the prophecy was symbolic. The belief system adjusted without admitting error. Sociologists have studied this pattern and found it common wherever strong belief meets public failure. Modern technology makes this easier. Online content can be edited, deleted, or buried. Old videos disappear. Posts are updated. New followers may never see earlier predictions. The record becomes fragmented. Without a clear timeline, the sense of failure fades. What remains is the feeling that something is still coming. Language plays a role. Predictions are often framed with conditional phrasing alongside absolute tone. Phrases like could happen or signs are aligning allow retreat if needed. At the same time, urgency is emphasized. This dual approach protects the narrative. Certainty attracts attention. Vagueness provides escape. Another tactic is shifting scale. If a physical event does not occur, the claim moves to energy, consciousness, or hidden dimensions. These cannot be measured or disproven easily. The focus moves away from the sky and toward personal experience. The apocalypse becomes internal rather than external. The original claim fades, but belief remains intact. These rewrites are rarely announced openly. They happen gradually. New explanations appear in comments, follow-up videos, or revised texts. The date is no longer mentioned. A new one may quietly replace it. The audience is encouraged to focus on the next signal rather than the last failure. Understanding this pattern matters because it shows how certainty can exist without accountability. In science, failed predictions lead to revision or rejection. In doomsday narratives, failed predictions lead to reinterpretation that preserves authority. The difference lies in standards of evidence. Moving goalposts also exploit hope. For some, the idea that disaster was delayed feels comforting. It suggests intervention or special status. For others, the delay keeps fear alive without resolution. Both responses maintain engagement. Recognizing this cycle does not require attacking belief. It requires memory, keeping track of what was claimed, when it was claimed, and what actually happened provides clarity. Without that, narratives float free of reality. Apocalypse dates feel powerful because they promise certainty in an uncertain world. When they fail, rewriting protects that promise. But the repeated need to rewrite is itself evidence. It shows that the story is adapting to reality rather than predicting it. Understanding this pattern prepares us to evaluate future claims more calmly. When the next date appears, history gives us context. Silence after failure is not mystery, it is revision at work. When we return to the ancient Mesopotamian sources themselves, a different picture comes into focus. The surviving texts were written between roughly 3,000 and 1,000 years before the Common Era, preserved on clay tablets in temple libraries and palace archives. They were not written to warn distant generations of cosmic threats. They were written to explain how society should function under divine order. The Anunnaki appear within this framework not as outsiders, but as part of a structured universe where gods, humans, and nature had defined roles. The central themes of these texts are order, duty, and balance. Gods are concerned with maintaining cosmic stability. Humans are tasked with labor, worship, and obedience. Kings serve as intermediaries, chosen by the gods to rule justly. Floods, famine, and war are interpreted as signs of imbalance, not invasions. When disasters occur, the response is ritual, prayer, and reform, not preparation for a returning entity. Law is a major focus. The famous law codes, such as those associated with Hammurabi, are framed as gifts from the gods. This does not mean gods physically handed down tablets from the sky. It means authority was grounded in divine legitimacy. Justice was sacred. Social order mattered because it reflected cosmic order. The Anunnaki appear as enforcers of fate and judgment, especially in underworld contexts, reinforcing moral consequence. Another recurring theme is stewardship of land and resources. Agricultural cycles, irrigation, and seasonal change dominate temple records. The sky is watched for omens related to harvest and kingship, not for incoming worlds. Celestial observation was practical and symbolic. Eclipses and planetary movements were signs, not vehicles. They were messages to be interpreted by priests trained in omen reading. Creation stories also reveal priorities. Humanity is created to work, to relieve the gods of labor, and to maintain temples. This reflects economic and social reality, not genetic engineering. The stories justify existing systems rather than challenge them. There is no narrative of gods leaving Earth and promising to return. Presence is constant through ritual, not episodic through arrival. Importantly, these texts were not hidden. They were read aloud, copied, and taught. Their meanings were shared within educated classes. If they contained warnings of returning beings, those warnings would be consistent and prominent. They are not. Instead, repetition emphasizes stability over disruption. Modern readers often approach these texts looking for secrets. Ancient readers approached them looking for guidance. That difference matters. When modern expectations are imposed, meaning shifts. What was once metaphor becomes mistaken for report. What was symbolic becomes literal. Scholars studying these texts compare hundreds of versions and fragments. Over time, patterns emerge. The Anunnaki are part of a moral and cosmic system, not a technological one. Their power is expressed through authority, not machinery. Their movement is symbolic, not orbital. Returning to the sources grounds the discussion. It reminds us that ancient people were not secretly describing modern fears. They were addressing immediate concerns about survival, governance, and meaning. The absence of return cycle warnings is not accidental. It reflects what mattered to them. Understanding what the sources actually emphasize does not close inquiry. It refines it. It helps separate ancient belief from modern projection. When claims about hidden histories arise, the texts themselves provide a steady reference point. They speak clearly when read in context. What they say is human, grounded, and focused on order in a fragile world, not on visitors waiting beyond the sky. The cost of cosmic fear is not abstract. It shows up in real lives, real decisions, and real stress. Throughout history, apocalyptic belief cycles have produced anxiety, isolation, and sometimes harm. When people believe disaster is imminent, priorities shift. School feels pointless. Work feels temporary. Relationships strain under constant urgency. This pattern has appeared repeatedly, from 19th century religious end-time movements to late 20th century panic around technology and calendars. In the year 1999, fears surrounding the Y2K computer problem led some families to stockpile supplies and withdraw savings. The world did not end, but the fear consumed attention and money. Around the year 2012, similar anxiety emerged tied to misinterpretations of the Mayan calendar. Mental health professionals reported increased stress in adolescents who believed global collapse was unavoidable. These effects were measurable even though the predictions failed. Cosmic fear isolates people by dividing the world into those who know and those who do not. Believers may withdraw from friends and family who question the narrative. Skepticism is reframed as danger. This separation deepens commitment and makes exit harder. Sociologists studying apocalyptic groups have documented how fear reinforces identity and loyalty at personal cost. Financial harm also appears. Some individuals spend money on survival gear, exclusive information, or guidance from self-appointed experts. Others make life decisions based on timelines that never arrive. When the predicted event fails, embarrassment and shame can prevent people from admitting error. Silence replaces discussion, allowing the cycle to restart later. Children are especially vulnerable. When trusted adults express certainty about doom, young minds absorb it without tools to evaluate evidence. Fear becomes background noise shaping development. Educators have noted drops in motivation and increased anxiety during periods of viral apocalypse claims. These effects matter even when the claims are false. None of this requires malicious intent. Many who spread these ideas believe they are helping. They see warning as protection, but intent does not erase impact. Repeated exposure to threat without resolution taxes mental health. The human nervous system is not built for constant emergency. Historically, societies recover from apocalyptic scares by restoring routine and meaning. When predictions fail, life resumes. But online environments preserve fear indefinitely. Old claims remain searchable. New audiences encounter them without context. The past never fully fades. Recognizing the human cost reframes the discussion. This is not just about astronomy or ancient texts. It is about how stories shape behavior. Fear changes how people live in the present. It steals attention from education, creativity, and connection. Addressing cosmic fear responsibly means emphasizing evidence, uncertainty, and patience. It means reminding people that not knowing is safer than constant alarm. The sky has always inspired awe and worry, but history shows that panic harms more reliably than imagined disasters. Understanding this cost encourages care in what we share and how firmly we claim to know the future. Clear thinking grounded in evidence helps communities stay calm and protect well-being during uncertain times ahead. If a body were truly returning on a measurable path through the solar system, discovery would not begin with an announcement from NASA. It would begin quietly, with data. The first people to notice would likely be astronomers analyzing small irregularities rather than watching the sky for spectacle. Changes in the motion of known objects would raise questions long before any image appeared. This is how discovery has always unfolded. The earliest signals would come from orbital calculations. Astronomers track planets, asteroids, and comets with precision built over decades. When an object moves differently than expected, that difference stands out. It is logged, examined, and shared. Researchers ask whether the cause is measurement error, known gravitational effects, or something new. This process happens continuously and often without public attention. Independent teams would notice similar patterns. One group might see unexpected clustering in distant objects. Another might detect small timing shifts in spacecraft tracking. These clues would not be dramatic alone, but together they would suggest influence from an unseen mass. Papers would be written, conferences would discuss it, debate would begin. This stage could last years. Only after predictions sharpened would telescopes be directed intentionally. Astronomers would calculate where to look and when. Multiple observatories would participate. This coordination is normal. Discoveries are verified by repetition, not authority. The first confirmed image might come from a university telescope, an international observatory, or even an amateur with the right equipment and timing. History supports this sequence. Uranus, Neptune, Pluto, and countless asteroids followed similar paths to discovery. None appeared suddenly. Each emerged through analysis, collaboration, and confirmation. Credit often went to those who noticed patterns rather than those who took the first picture. News would not break as secrecy. It would break as competition. Discovery brings recognition and funding. There is incentive to publish quickly but accurately. Suppressing such a finding would require cooperation against personal and institutional interest. That cooperation would have to span nations, cultures, and careers. Once confirmation occurred, public discussion would follow rapidly. Data would be shared, models would be refined, risks, if any, would be assessed openly. Governments would not control this process easily because they do not own the data. Astronomy operates through transparency because prediction and safety depend on it. Importantly, the object would not be a surprise to the public at the moment of danger. By the time images circulated, years of analysis would already exist. Timelines would be discussed. Uncertainty would be acknowledged. There would be no sudden reveal. This realistic path matters because it contrasts sharply with fear-driven narratives. Those narratives imagine discovery as a secret known only to a few. Reality spreads knowledge outward from many sources. It is slow, layered, and resistant to control. If something were returning, the sky itself would reveal it through motion and influence. Many eyes would notice, not one agency. Understanding this removes drama and replaces it with process. Discovery would unfold as a shared human effort, not a hidden countdown. The idea of a return cycle may say more about human culture than about the sky. Long before modern astronomy, societies explained uncertainty through repeating patterns. Floods returned, seasons returned, empires rose and fell. History felt circular rather than linear. In this worldview, time moved in cycles, not toward an endpoint. Myths reflected that rhythm. Gods departed and returned symbolically. Order collapsed and was restored. These stories helped people cope with instability. In ancient Mesopotamia, cycles governed everything. Agricultural life depended on predictable flooding and planting seasons. Religious calendars followed repeating rituals. Kingship itself was framed as renewal. When a king failed, divine favor was believed to withdraw. When a new king rose, favor returned. These were not predictions of physical events. They were moral explanations for change. The return cycle concept fits neatly into this tradition. It promises meaning in chaos. If disaster looms, it is not random. It is part of a pattern. Someone has been here before. Someone will come again. This idea reduces fear by giving it structure. Even terrifying events feel more manageable when they follow a script. Modern culture inherits this pattern unconsciously. Technological change accelerates faster than social adaptation. Economic crises repeat. Environmental concerns cycle through attention and neglect. In this environment, the idea of a cosmic return becomes a powerful metaphor. It externalizes anxiety. Instead of complex systems failing, a single cause approaches from the sky. Psychologists note that humans search for narrative coherence during stress. Cycles provide that coherence. They suggest inevitability and release. Something bad happens, but it ends. Then it happens again. The unknown becomes familiar. This familiarity can be comforting even when the content is frightening. The language surrounding return cycles often mirrors cultural fears of judgment and renewal. Collapse is followed by cleansing. Destruction clears the way for rebirth. These themes appear in religious texts, literature, and modern film. They are cultural constants, not astronomical observations. When return cycles are framed as literal events, metaphor hardens into belief. The symbolic becomes physical, but the persistence of the idea across centuries suggests it fulfills a psychological role. It explains why societies facing uncertainty repeatedly imagine external forces enforcing reset. Astronomy does include real cycles. Orbits repeat, comets return, eclipses follow patterns. But these cycles are measurable and indifferent. They do not judge or punish. They do not care about human behavior. Cultural return cycles do. They carry moral weight. Separating metaphor from measurement helps clarify the discussion. When someone speaks of a return cycle, the question becomes what kind? Is it a physical orbit supported by data, or a narrative pattern expressing collective anxiety? Confusing the two leads to fear replacing analysis. Understanding the return cycle as metaphor does not dismiss curiosity about the universe. It grounds it. It reminds us that humans project meaning onto the sky. We always have. The danger arises when metaphor is mistaken for mechanism. Recognizing this allows for a calmer view. The sky continues its motion regardless of human stories. Our fears and hopes shape how we interpret it. When those interpretations become literal threats, it is worth asking whether the cycle we are sensing is cultural, not cosmic. This perspective helps reframe fear as information about ourselves rather than about something approaching unseen. NASA's knowledge does not live behind closed doors in a single room. It lives in databases, papers, archives, and public servers accessed daily by researchers around the world. From its earliest years, NASA was structured around open science. Data collected by missions is released after processing and validation so others can analyze it independently. This practice is not optional. It is required for credibility. When NASA launches a telescope or spacecraft, the instruments are designed with clear goals. Those goals are published before launch. The data collected is logged, time-stamped, and calibrated. After an initial period reserved for mission teams, the data becomes public. Anyone with the skill and interest can download it. Universities, private researchers, and even students regularly use NASA archives for original research. Peer review is central to this process. When NASA scientists make claims, they do so through scientific journals. Those journals require methods, results, and uncertainties to be clearly described. Other experts review the work before publication. If flaws are found, they are challenged. This review does not guarantee perfection, but it prevents quiet control of outcomes. Disagreement is visible. NASA also collaborates extensively. Many missions are joint efforts with space agencies from Europe, Japan, Canada, and elsewhere. Instruments are built by international teams. Data flows across borders. This structure makes secrecy difficult because information is distributed by design. Public communication adds another layer. NASA publishes findings through press releases, briefings, and educational material. These announcements are cautious. They avoid certainty beyond evidence. This caution is sometimes misread as evasiveness. In reality, it reflects responsibility. Overstating results damages trust. Importantly, NASA does not decide truth alone. Many discoveries credited to NASA are confirmed or challenged by non-NASA teams. The discovery of exoplanets near Earth-sized worlds involved telescopes operated by universities and international observatories. Near-Earth object tracking involves global networks. NASA contributes but does not dominate. The agency also documents uncertainty clearly. When something is unknown, it is labeled as such. When limits are placed, they are specified. This transparency allows others to build on the work or propose alternatives. It also means claims about hidden knowledge can be tested against published material. Historically, when NASA has been wrong, corrections followed publicly. Early Mars missions speculated about canals. Better data ended that idea. Pluto was once considered a planet. Improved understanding led to reclassification. These changes were debated openly. They show that NASA adapts to evidence rather than defending fixed narratives. Claims that NASA hides major discoveries misunderstand incentives. Scientific careers advance through publication, not silence. Discoveries bring funding and prestige. Hiding something as significant as a massive returning object would require thousands of people to act against personal interest across decades. There is no historical example of such sustained coordination. NASA's archives remain available long after missions end. Older data is reanalyzed with new techniques. Sometimes new discoveries emerge years later. This openness allows history to be revisited. Secrets do not survive that process. Understanding what NASA actually knows requires looking at what it publishes and how it publishes it. Knowledge emerges through accumulation, comparison, and correction. It is slow, visible, and shared. This structure does not promise certainty about everything. It promises accountability. Within that system, extraordinary claims must appear in data and survive review. So far, claims of a hidden return cycle have not. What NASA knows is what can be measured, tested, and shared. Everything else remains speculation until evidence enters the same public space. You do not need secret access to test extraordinary claims. Simple reality checks exist, and anyone can use them. The first is consistency over time. When a claim predicts a specific event, write down the date and the details. When the date passes, check whether the explanation changes. History shows that reliable knowledge tightens predictions, while unreliable claims retreat into vagueness. The second test is specificity. Real scientific claims tell you where to look, how to measure, and what would prove them wrong. Ask what size the object is supposed to be, where it should appear in the sky, and what effect it should have. If these details are missing or constantly revised, there is nothing to test and nothing to confirm. Another check is source tracing. Follow a claim backward to its origin. Does it rely on peer-reviewed research? Or does it circle back to the same small group of videos, books, or posts repeating each other? Independent confirmation matters. In science, new ideas spread outward. In belief systems, they echo inward. You can also compare claims against publicly available data. Sky surveys, asteroid catalogues, and mission results are accessible online. You do not need to interpret raw measurements. You only need to see whether professionals across many institutions agree something unusual is present. Silence across independent sources is meaningful. A powerful test is proportionality. Ask whether the proposed cause matches the supposed effect. A planet large enough to disrupt Earth would also disrupt other planets. Those disruptions would be noticed first. If the claim jumps directly to catastrophe without explaining intermediate effects, it skips essential steps. Another reality check is track record. Look at past predictions made by the same source. Were they accurate? Were errors acknowledged? Reliable sources correct themselves openly. Unreliable ones explain failure away or delete it. Memory protects clarity. It also helps to examine incentives. Ask what the source gains if you believe. Attention, money, status, or belonging can influence certainty. This does not mean the claim is false, but it means extra caution is warranted. None of these tests require advanced science training. They require patience and honesty. They slow the rush to conclusion. Fear demands speed. Understanding benefits from delay. These checks do not remove wonder from the universe. They protect it. They ensure curiosity remains grounded rather than exploited. When you apply them, many frightening claims lose urgency. What remains are genuine questions that science continues to explore carefully. The goal is not to dismiss everything unknown. It is to separate what is unknown from what is unsupported. When you can do that, you no longer need to rely on authority or suspicion. You can evaluate claims yourself. This ability matters because stories about hidden dangers return again and again. Tools that help you test them return as well. Use them. They keep curiosity alive, without letting fear take control of your time, attention, or trust. Clarity grows when questions meet evidence, and patience replaces panic over time for everyone. So does NASA know. The most defensible answer is grounded in evidence rather than feeling. NASA knows what has been observed, measured, and verified through shared scientific process. It does not know of a hidden planet returning on a destructive cycle because no data supports that claim. This conclusion is not based on trust in authority, but on how knowledge of the sky is actually built. Across decades, the solar system has been watched continuously. Planetary motions are tracked. Spacecraft are navigated using precise gravitational models. Infrared and optical surveys have scanned the sky repeatedly. These efforts involve NASA, but also universities, private observatories, and international agencies. The results are consistent. No massive object matching the Nibiru narrative exists within the ranges that would matter for Earth. If such an object were real, NASA would not be the sole holder of that knowledge. Discovery would emerge from patterns noticed by many observers. It would be debated, published, and tested. History shows this clearly. Major discoveries are noisy, not silent. They provoke disagreement and refinement, not secrecy. Silence across independent datasets is not evidence of suppression. It is evidence of absence. NASA's statements reflect this reality. When asked about Nibiru or Planet X, the agency explains that there is no observational basis for those claims. This answer has remained stable across years because the evidence has not changed. When evidence changes, NASA updates its conclusions publicly. That pattern is visible throughout its history. What NASA does know is that uncertainty remains at the edges of detection. Small, distant objects may exist far beyond current reach. These possibilities are acknowledged openly. They do not threaten Earth. They do not follow dramatic return cycles. They remind us that not knowing everything is different from hiding something. The appeal of believing NASA knows a secret is understandable. It gives shape to anxiety. It suggests order behind fear. But the universe does not organize itself around human narratives. It follows physical rules that leave traces. Those traces are visible to anyone trained to look. The Anunnaki return cycle combines ancient myth, modern reinterpretation, and contemporary fear. When examined carefully, each layer separates. Ancient texts do not describe returning planets. Modern astronomy does not detect them. Cultural patterns explain why the idea persists. So does NASA know. Yes, it knows what the data shows. It knows what has been ruled out and what remains possible. It knows that extraordinary claims require extraordinary evidence. It also knows that fear spreads faster than correction. The most honest conclusion is calm. There is no hidden countdown. There is no approaching world known and concealed. There is a vast universe studied imperfectly, but openly. Curiosity belongs there. Fear does not have to. Understanding this does not close the door on wonder. It opens a clearer one. It invites engagement with evidence, patience with uncertainty, and respect for how knowledge grows. The sky remains full of mysteries worth exploring, without needing a secret to make it meaningful for humanity today.